to Technical Utkranti, and today we'll be looking into how to find kth element, kth largest element uh, from two arrays that are sorted. All right. So how are we going to do it? Before that, have a look at the thought for the day. This is in Hindi, and it basically means that ones who desires very less or nothing don't have to bow down in front of anyone. So they are like the boss of the boss. All right. So these are the questions that we have done till now under binary search. And let's have a look at the question. So you are given two sorted arrays, nums1 and nums2, just like the previous question we have done in the series. And in the previous question, we had to find the median of the two arrays. Here, we need to find the kth element of the two sorted arrays. For example, 135 is nums1 and 0246 is nums2. And we need to find the fourth element from the starting. Then it would be 3. 0, 1, 2, 3. 3 is the fourth element. All right. How are we going to do it? All right. So we have these two arrays and we need to find the fourth element. All right. So what we'll do is we'll have if this is the combined sorted array of these two arrays, then we need to have a division such that we have four elements over here and the remainder, which is if this is m and this is n, m plus n minus k. So k is equal to 4 here and m plus n minus k over here. So basically we need to have a partition in these arrays in a way such that we create one array of size k and another array of size m plus n minus k. So what we'll do is we'll take this particular array and start applying binary search on it. So we'll have L is equals to 0 and H is equal to 3, which basically means we can take none elements from this and at the maximum 3 elements from this particular array. Right? And then we compute our cut 1, which comes out to be, let's say, 1. Right? 0 plus 3 by 2 is 1. So this is the cut 1. Okay. And cut 2 comes out to be k minus cut 1, right? Which is 4 minus 1, 3. Which basically means that if we are picking one element from this particular array of size m, then from the array of size n, we need to pick three elements in order to have four elements over here, right? 0, 2, 4, 6. And here cut comes over here, cut 2 comes over here. All right. So this becomes L1 and this becomes L2. This becomes R1. This element becomes R2. So this, this, and this. These are the elements that we are concerned with. All right. Now what we need to see, since these and this element forms the left half and this particular element forms the right half, we need to ensure that L1 should be less than R1 and R2 and L2 should be less than R1 and R2. Correct? Because if we can ensure this, then the remainder of the elements will automatically be lesser than or equal to R1 and R2 because this is ascending order arrangement. All right. L1 will automatically be less than equal to R1 because this is ascending ordered array. Similarly, L2 will automatically be less than or equal to R2. What we just need to ensure is L1 should be less than equal to R2 and L2 should be less than equal to R1. Alright. So L1 is less than equal to R2, but L2 is not less than equal to R1. Right? So what we need to do? We need to shift cut2 over here. And in order to move cut2 over here, we need to move cut1 this side. Right? In order to move cut1 towards the right side, we need to make L is equal to cut1 plus 1. So L becomes equal to 2, H is 3, cut1 comes out to be 2. So this is cut1. Alright. And cut2 also comes out to be equal to 2. So both cut1 and cut2 are 2 now. Again we'll mark our L1, L2. So this is L1, this is L2, this is R1, and this is R2. Now L1 is less than equal to R2 and L2 is less than equal to R1. So this is the perfect partitioning that we wanted to achieve. All right. Now what will happen is we have four elements on the left half, which is 1, 3 and 0, 2. So the last element of the left half would be the kth element of the entire sorted array, right? Now this one could be the last element or this one could be the last element because both these subsets are sorted. So what we'll do is we'll return the maximum of L1 comma L2. This will be the kth largest element. All right. So I hope you understood the approach. Now let's look at some corner cases. And in the previous case, we saw that k is equal to 4. Alright. Now let's consider the case when k is equal to 2. When k is equal to 2, we can pick a minimum of 0 elements from this particular array. But what is the maximum number of elements that we can pick from this array? If k is 2, which is less than m. So if we pick 3 elements from the array, we cannot pick a maximum of 3 elements if we want to do the partition of size k, right? So what we'll do is we'll pick a maximum of k elements when k is less than m. All right. Now, when k is greater than n, what happens? When k is greater than n. So let's say we have k equals to 5. Right? When k is equal to 5, we can pick a maximum of 3 elements from the first array. And what is the minimum number of elements that we can pick from the first array? If we pick 0 elements from the first array, then we need to pick 5 elements from this array. So that is not possible because it has only 4 elements. So what we'll do in that case, we'll pick k minus n number of elements. So k minus n would be 1. So when I pick minimum of 1, then I have the freedom to pick 4 elements from the second array, right? So that is how the division of size k could be done in these two corner cases when k is less than the smaller array and when k is greater than the larger array size. So now let's have a look at the code. So here I am just ensuring that I am beginning or I'm applying my binary search on the minimum array, minimum sized array to ensure that the time complexity is as low as possible. Here I am identifying my L and H. So when k is less than m, I am ensuring I am picking a maximum of k elements. When k is greater than n, then I am ensuring that this is the low L value and otherwise L and H are equal to the lower and upper bounds of the smaller array. And this is the binary search. So I'm computing cut1 and cut2. So if cut 1 is 0, so this is another corner case. If cut 1 is 0, then there is nothing on the left of the cut 1, right? So I pick a maximum, like very highly negative value. Similarly, if cut 1 is m, then I take r1 as a highly positive value. Similarly for cut 2, all right, while calculating L2 and R2. So this was explained in the previous video also, right? Why am I taking this highly negative value? Because when cut 1 is 0, uh, the comparison with of L1 with R2 is inconsequential. It is not required. But since we have to write the algorithm for all kinds of values, that's why we have to give L1 some value, so that the comparison of L1 and R2 always is always true, right? This comparison is always true. All right. And finally, we are writing the condition. If our solution has resulted in appropriate cuts, then we can return the max of L1 and L2 as the kth element. Otherwise, we can shift accordingly, as I had explained in the algorithm. So let's submit it and see if our code is acceptable. Yes, it is. So I hope you understood the question, the approach, and the code. If you did, please give it a thumbs up and subscribe to my channel. Thank you. Bye bye.